Right. Now we're ready to talk about the measures of variation. There are actually, I don't know, 6 or 8 different measures of variation. Wait, we're going to learn 3. If you take a full-blown stat class, you might get exposed to all of them, though. There are many, many more measures of variation than there are measures of central tendency. Okay, what's it mean to vary? If you're studying measures of variation, how different things are. So whereas on central tendency we were trying to find the center of the data, now we're trying, yeah, how much is this data varying? And there's a lot of ways to figure the variation. Okay, you just used the one word, the most common word that we think of, range. You learned range somewhere back in the deep dark past. How do you calculate the range of a set of data? Very small. So, yes, range is highest value minus lowest value. So, in this, in this parenthesis here, I have given you this lovely little set of data. How would you find the range of this set of data I just gave you?
36 minus 6 equals 30 equals 9.
All right, we just jumped on that real fast. So, yes, on that particular set of data, high minus low means there's a range of 30-somethings. We don't know what this data is. So I know that I had a range of 30. Okay. Probably the most important measure of variation that the statisticians use the most is what's called standard deviation. Now, I don't think you've done this one before. Okay, I'm going to give you the word meaning of this by definition, but you can't translate these words exactly into how you calculate it. So I'm putting this word in quotes, because it's not a true average, but it's the average of how much each piece of data varies from the mean. Okay, average of how much each piece of data varies from the mean. Okay, and so that's the first thing. If it's how much each one varies from the mean, what's the first thing you got to figure? You have to figure the mean. So yes, so first step here, I'm going to use the X bar symbol for mean. What would I have to do to find the mean? I would need to add all those up. Okay, somebody with lightning fast fingers is adding those up while I'm looking for my notes, and I will know how much they add up to. They add up to 144. Okay. So then what? Divided by 8. 3, 4, 5, 6, 7, yeah. So and 144 divided by 8 turns out to be a mean of 18. Okay. So now, here's where you got to translate the word. How much does each piece of data vary from the mean?
18 minus 6 equals...
Okay, why is she saying 18 minus 6?
Because how much is your range?
You got to figure out how far each number is from the mean.
This is annoying.
So you certainly hope I don't give you a very big set of data to do by hand, don't you? So yeah, you have to subtract each number from the mean. So you got to go, what's 6 minus 18? And you, technically it's negative 12. Well, until I tell you more of the story. 8 minus 18 is 10, negative 9, negative 7, negative 6. Then, whoa, positive 10. 34 minus 18 would be 16. 36 minus 18 would be 18.
Everything that is greater than 18 is positive. Everything is
yeah. So all the numbers that were below 18 came out with negatives, but all the numbers that were above 18 came out positives. Now, it says, this is where the definition, the word definition goes astray. It says the average of how much each one varies. So you would think you should average these This is how much each number varies. But what happens if you add that up? Nope. Add them up.
No.
Negative 22, negative 31, negative 38, negative 44. So the negatives add up to negative 44. The positives, 18 and 16 is 34 plus 10 is, they add up to 0. Well, if it's the mean, shouldn't it be in the middle? So they should be equally on either side of the mean. So it should add up to 0. So then what good does that do me if every time I do this, it always adds up to 0? Yeah, okay, well, here's where it goes astray. You're right, the negatives are messing us up. Okay, so what are ways we mathematically know to make things become positive? Absolute value is one way. Just make them all positive and add them up. That's a measure of variation called the mean variance. We aren't doing that one. Another way is to square them. And so I don't know why statisticians decided they liked this method best, but yeah, they went, we're going to make them all positive by squaring them. So you literally have to square each one. And then find the average. Now, I'm going to tell you right now, do not, when you're doing these by hand, do not sit there and write down what all those numbers are squared. Do not write down 144, 100, 81, 49. You do not need to write that out on your paper. Go to your calculator and start typing 12 squared plus 10 squared plus 9 squared plus 7 squared. You're squaring them, so are the negatives going to matter? Don't bother to type the negatives in. Just go to your calculator, type that all in, squaring each number as you go, much, much faster. But we do need to get them all added up, so you're going to be putting a plus between them. But you don't need to list out every separate number on your paper. If that helps you, do it, but you're certainly not required to. So if you actually do 12 squared plus 10 squared plus 9 squared, etc., 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 this baby adds up to 1,090. Okay? Tyler wants to square root it. Okay. I don't have this. Can somebody do square root of 1,090 for me? Real quick. If you square root it right now, I want you to see, does the answer make sense? 33 point something? Okay, so roughly 33. Okay. Does 33 look like it'd be the average amount these were varying? There wasn't a single one there that was varying by 33, so how could that be right? What do we need to do before? You're right, we need to square root it. Yeah, if we're finding the so-called average, then yes, you need to divide by 8 of them first, and then square root it, the whole thing. Okay, 136.25. So you would be doing the square root of 136.25. And that sounds good, 11.67. Does that look more like the average variation? If you're looking at these individual numbers, 12, 10, 9, 7, 6, somewhere 16, 18, that looks a little more reasonable. Now, I will tell you, because you're subtracting each number from the mean, if you have some wild values, they make some of these variations come out bigger, and then when you square it, this one is thrown off by wild value some, just like the mean is thrown off by some, if you have really high, really low numbers, standard deviation will be thrown off a little bit. If you've got some extra high variations, it's going to make this come out a little high. Yeah, but statisticians actually like that on variation. They would rather know that they have too much variation than too little. So standard deviation you're going to discover, particularly if you go on with more stats, we use this in a ton of other formulas. Mean and standard deviation are probably the two most quoted statistics ever. So we like standard deviation a lot. So I don't have room. We'll make room. Oops. Oh well. All right. Symbols for standard deviation. Okay. If you are doing a sample, standard deviation is just an F. If you are doing the entire population of something, it's a Greek letter. Actually, they'll tell me they think it looks like a whistle.
I think it looks like an I. I think it was a fat shit.
That's actually lowercase sigma. That's lowercase s. The capital big E looking thing was capital S, capital sigma. This is lowercase
Do you
sigma.
have to know these symbols for
Yes.
what?
Because I expect you to know them to do statistics, and that's how your calculator delivers them to you. So, yes. You have to know a sample from a population. Just to show you, come on, dude. Back here when we were looking at all this data it calculated, and up here at the top, you'll notice you have S sample standard deviation, population standard deviation. Okay, for us this year, I'm not getting that specific, there's actually a slight difference. When you calculate sample standard deviation, instead of dividing by 8, you divide by 1 less, you would have divided by 7. We aren't doing that this year, so you're going to always use the whistle one for this year. I get specific about it. Pre-calc, we actually break it down and do them both, but for right now, you're going to use the one with the whistle. So, that you'll be looking for standard deviation quite a bit on those. Okay. You'll notice over here, if you haven't already copied it, I wrote it in steps for you, how to find standard deviation. You find the mean, and it takes several steps. Find the mean, you have to subtract every number from the mean. So you're going to get 8, data minus mean.
Okay.
Take the data, we did 6 minus 18, 8 minus 18, 9 minus 18. We subtracted every number from the mean. Then we squared all those numbers. Found the mean of them by adding them up and dividing by 8. And then lastly, we square rooted it. So, it's not hard, and people never have trouble with standard deviation once you practice a couple. You do need to practice a couple until you get good at standard deviation. But it is a really, really, really important statistic. It's going to show up next class. And there's one more. You're right. How are we on time? Okay. Do I need to do another standard deviation, or do we just get the basic process? Okay, I'm going to stop